right, we're on page 186. You'll see under number 1, there's a triangle there on 186. We're going to do some vocabulary. There's a cool little piece of information in your book that I didn't know before. So if you look at that little blurb off to the left, I'm going to read that. I learned this morning when I read it today. It says this: the name isosceles is derived from the Greek iso, which means same, and skelos, which means leg. So the word isosceles from the Greek literally means same leg. So every isosceles triangle has the same leg. Like you have 2 legs that match, the triangle has iso, skelos, same legs. So please, in the picture here, let's go ahead and mark it isosceles. So we're going to say 2 the same, and those are called legs. That's a vocabulary word today, legs. There will be 2, they will match. That's why I put the same marks on them. Here's some other vocabulary you'll need to know. The leg that doesn't match, it has a name also. It's called the base. The leg that doesn't match is called the base. Will the base then always be on the bottom?
No.
No. If I draw my triangle like this, then this is my base. It's not at the bottom. Base doesn't mean bottom. Base means the leg that doesn't match. There are such things called base angles. There's 2. Can you guess where they're at? Base angles. Well, if this is the base, then this is a base angle and this is a base angle. Pretty easy so far, but definitely some words you need to know. This angle has a name also. This is called, the one that's not touching the base, that's called the vertex angle. So if a homework or quiz question says the vertex angle is 55, you'll have to know your vocabulary to know where to put that 55. If you have your vocabulary, you know where everything is. Yesterday we learned 2 theorems. They're on this board. They'll be here for a couple days. When we take our quiz, of course, we'll take them down. Let me review them real quick. Triangle sum theorem. That's when you had your paper and you cut or tore off the angles, and your 3 angles made a straight line, which is 180 degrees. 3 angles in a triangle always add up to 180. We're actually going to use that today also. 3 angles always add up to 180 degrees in a triangle. The second theorem was called the exterior angles theorem. So if you're looking for the exterior angle, it's going to equal the sum of 2 other angles. And those are what we call the remote angles, the ones that are far off from the exterior. Today we're learning 2 theorems, but they're very, very similar. So let's get started with that. Maybe just in this side margin like you did yesterday. Today's theorem is called isosceles triangle theorem. We're going to write this in the margin on either side. Please spell isosceles correctly. It's in your book. It's actually highlighted. Isosceles triangle theorem. We're going to write it in if-then form. So let's put if here and here. Here's what the theorem says. You can copy it just like this. If the triangle is isosceles, comma, if the triangle is isosceles. Then base angles are congruent. We'll draw a picture for this. I'm going to put the then in green. So I'm going to draw an isosceles triangle. Remember the Greek iso, same leg. So iso, isosceles is a triangle with at least two sides the same. If you know that, if the direction says isosceles or the picture says it's isosceles, then I'll do it in red. You don't have to. The base angles are congruent. Does it matter which ones I call the base angles? Yeah. If these are the legs, then this leg, this side is the base. So these angles will always match what we call congruent. That's the theorem for today. You see two sides the same, isosceles, two angles are the same, and it matters which two. The other theorem for today has pretty much the same name. It's called the isosceles triangle converse theorem. So you can write it right below or wherever you have space. Isosceles triangle converse theorem. It's also in if-then form. Hi, I keep your mess. Anybody happen to remember what the word converse means? It's been a long time. We learned converse, inverse, contrapositive. Converse is flipping the if and then. So all I have to do is take this and flip it. So it's going to read if base angles are congruent. If base angles are congruent, then the triangle is isosceles. What's the difference? It's just what you start with and what you end with. So if I draw a picture here I'm starting with base angles congruent. So if you're told that these angles match, then you would know it's isosceles. It's same leg. It's two legs match. Then you would know that. What's the point of writing it and then doing the converse? Why do we do that? Well, let's take this statement for a second. No, thank you for asking. Let me make up a statement. If an angle is 17 degrees, then it is acute. Is that true? If an angle is 17 degrees, it's got to be acute. That's true, right? If it's 17, it's acute. True. If I do the converse, if I flip those, if an angle is acute, then it is 17 degrees. Is that always true? If it's acute, it's got to be 17? No. I'm doing this to show you that you can't just flip statements whenever you want. Just because this statement is true doesn't mean when you flip it, when you do the converse, it's going to be true. If your book tells you, hey, you are allowed to flip it, then you know that it is true. So not in math can you always flip statements around, but this is one case where you can, so that's why your book draws attention to it. The if then could be flipped and it's still true. All right, let's do some practice problems, starting with number 7. We're going to want to draw a picture. It says this, number 7, the measure of the vertex angle of an isosceles triangle is 80 degrees. What is the measure of a base angle? Okay, so let's just start with the triangle. We're going to label everything we know. The vertex angle of an isosceles triangle is 80. I don't really know where the vertex angle is yet because I don't have much drawn. But I do know it's isosceles. So let's iso, same leg it. Give it 2 legs the same, isosceles. What did we just learn? Let me delete that page. About if it's isosceles. If it's isosceles, aren't there going to be 2 angles the same? So let's go back to our picture. We know it's isosceles. That's in the directions. The theorem today tells us if it's isosceles, the base angles are congruent. So this has got to be the base. So that means these angles match. Now, do you know where the vertex angle is? Yeah, if these are the base angles, then this one has to be the vertex angle, and that was listed as 80. So that took a little bit of setup. We kind of had to know our vocabulary. When the directions tell you it's isosceles, start there. 2 legs the same. Anytime it's isosceles, base angles will also be the same. Do that next. Then label anything else, like it says vertex angle is 80. Now, what's the question? What is the measure of a base angle? What do you think? 50 is correct, but how did you get that so fast? Good. So he used the theorem from yesterday, which says all 3 angles in a triangle add up to 180. So he took 180 and he got rid of 80. And then he knew what's left was divisible by 2. Maybe he didn't quite get there so fast. Here's another way you could kind of write it out. If this is what I want, I'm going to call that base angle X. And if these match, they're both X. Now I can write out my equation. 80 plus X plus X. All 3 angles add up 180 degrees. If you can see it as quick as Keenan did, great. I would not require work for that. Hopefully he has a picture. I'm just doing it for the rest of us that might not have got there quite so fast. So my 3 angles add up to 180 degrees. Let's do some algebra. X and X is 2X. Keep going. You got a calculator. Find X. Questions on this one? I know I'm done with X because that's what the base angle is labeled, and it says how big is the base angle. X is 50. That's 50. Yeah.
Where'd you get 2X from?
Because I'm adding 3 angles.
Oh, those 2X's.
Yep, they're both the same. Yep. All right, let's draw a picture for 8 and see if we can figure it out. 8 says the measure of one base angle of an isosceles triangle is 25. What is the measure of the vertex angle? Try to draw a picture first. What are we drawing? Well, we know it's isosceles, so we'll start with same leg. Our theorem says if it's isosceles, base angles also match. So right after I draw my isosceles triangle, I know where the base is. I know those base angles match. What else do I know? One base angle is 25. There's my picture. I'm going to give you time to work on it. You could put X where you want your variable to be. The vertex angle is what we want. That's got to be that angle up there. And according to my picture, if the base angles are the same, this one's also got to be 25. The triangle sum theorem says all three angles add up to 180 degrees. This is another one I would say if you drew a picture and then just put 130, I would accept that without other work. Any questions on 8? Okay, we're going to try 2 more, starting with number 9. Number 9 has a picture. What's it say? It says solve for x. Not a lot of words here. It doesn't tell you in words it's isosceles. Does the picture tell you it's isosceles? Yes. Does the picture tell you iso, skelo, same leg? Yeah. Yes, it does. So I would go ahead and when it says 5, 5, I would do that because that's what we're used to seeing. And what should we do as soon as we have isosceles 2 legs alike? The base has 2 base angles alike. I would mark that right away. That's the theorem for today. Whenever you have isosceles, 2 sides alike, the base angles are alike. Okay, I'll give you time to do some brainstorming, see what you can come up with. What do we think about doing this? Just what we do? No. No, look at your picture. I know some will accidentally do that. Are these the 2 that are marked alike? No. No. So that would be wrong. Those aren't alike. These are alike. So what I would do is if this is 2x plus 3, this has also got to be 2x plus 3. Now I can use triangle sum theorem. Add 3 angles to 180 degrees. Questions before I do the algebra? So that's 7x. Whoa, I think I did something wrong. 7x. Oh, it should be 5 here, right? Yep. That's plus 5. Yep. There we go. Just do this. 25 is x. Am I done? Is this my answer?
Yes.
Oh, yeah. If you read the question, it just says solve for x, so you're done. There definitely will be times where it says find the angle. You'll have to plug in x, but not this one. All right, the last one we're going to do is 14. Lots happening here. If we draw a picture, it will be a lot easier. Let me read it for you. Number 14. In triangle ABC, angle A is congruent to angle C. If AB is 4x plus 25, BC is 2x plus 45, AC is 2x minus 15, determine the lengths of the three sides. If you can do this in your head, I won't allow it. I'm not saying you can't. I'm saying you got to show me something. Let's start by drawing a picture. Do the words say it's isosceles? No, so I cannot draw it as isosceles. Let's label it, though, ABC. It says angle A is congruent to C. Let's mark those angles alike. Now let's pause because that makes me think of a theorem. Look at your theorems, or I'm going to pull mine back up here. See this second theorem down here? Let me read it again. If base angles are congruent, which is what we have, then it is an isosceles triangle. So even though the words didn't say it, because the words were base angles were alike, our theorem tells us it will have two sides alike. Does it matter which two? Yes. How do you know which two? One's a base and two are legs. Well, if these are alike, aren't those the base angles? So this has got to be the base here, right? So that means it's these that are alike. Questions on my picture so far?
No.
It says AB. Is AB a side or an angle? It's a side. 2 letters is always a side. So the length of side AB is 4x plus 25. Then it tells you the length of BC. That's side BC. Then label side AC. Oh my word, Carm. That's so much work.
Yeah.
Yeah. Okay, so our picture's done. Now we have to do some thinking. What's the question? Determine the lengths of the 3 sides. Mm-hmm. If you're stuck, just look at your sides. How are they marked? What do you know? Try something. somebody tell me where to start for anybody who's stuck? Y'all are working, I just don't know what I'm doing.
Okay, I did something wrong.
Nick, what are you writing? Can you tell me?
Um.
What did you start with to figure this out?
Added all the sides.
Added all the sides up to the 180? Okay. I'm glad you said that because I was going to talk about that. Everybody stop, please. I'm guessing there's a handful that did this. This is actually not right. I'm guessing some did this side, plus this side, plus this side, add up to 180. Did some of us do that?
Yes.
Okay. So my question to you is, when we did that cutoff thing, did you cut off 3 sides or 3 angles? You did 3 angles, right? Don't 3 angles add up to 180 degrees? Yeah, sides actually don't add up to 180 degrees. It's always 3 angles. I was going to talk about this no matter what, because this always happens. It's a common mistake. Please don't add the sides up to 180 degrees. Though there's actually a quicker way to do this, since that way doesn't work. Look at your 3 sides. Didn't you label this side matching this side? So wouldn't this have to match this? There you go. That one's a pretty quick one. These are equal. So yes, it matters which sides we set equal, but that's what our picture's for. Once you find x, then we can find the 3 sides. So you'd plug x back in to find this side. Anybody need more time getting the 10? Okay, so I'm plugging it back in. If I plug 10 in here, 2 times 10 is 20, plus 45 is 65. So BC is 65. Plug 10 in here for x. 4 times 10 is 40. Plus 25 is 65. That worked out well because they're supposed to be alike. Congruent. Do I need to plug 10 into this side? Well, it's the question. Find the lengths of all 3 sides. So yeah, I found the length of 2 sides. Plug it back in to find the length of the 3rd side. 3 times 10, 30. Minus 15 is what?
15.
15. Notice I labeled them so I don't just have 65, 65, 15. So on our homework, let's make sure we're drawing pictures. I'm going to go ahead and put the homework up, and then I'm going to help you with question 17.